Hello dear students. In this video, I'm going to discuss the question number 3 and question number 4 of our book Objectives in Civil Engineering by Gupta and Gupta. So the question number 3 of our chapter in fluid mechanics is the unit of kinematic viscosity is, as we have discussed earlier, we have to deal with two types of viscosities in fluid mechanics. One is the kinematic viscosity and another one is the dynamic viscosity. The unit of dynamic viscosity is Newton second per meter square, and the unit of kinematic viscosity is meter square per second. Let us look at the derivation of this unit for kinematic viscosity. For dynamic viscosity, the law governing is the Newton's law of viscosity, which states that tau is equal to mu times W upon tau y, where tau is shear stress, and W upon tau y is the velocity gradient, that is the difference in velocity between two layers of a fluid at a distance of dy. Okay, so the unit of shear stress is similar to that of pressure, which is Newton per meter square. That equals mu times du upon dy, where du is velocity, that is meter per second, and dy is the distance between two layers in a fluid, which is dy, hence meters for distance. If we rearrange this equation, mu equals Newton times meter times second times meter square times meter. Newton times meter and second upon meter square times meter, which equals Newton second upon meter square, which gives us the unit for dynamic viscosity. Now, kinematic viscosity relates with dynamic viscosity through this equation, that is nu equals mu upon rho. Now nu equals, we already have the units for mu, which is the dynamic viscosity, and that is Newton second upon meter square times rho is the density, which is mass per unit volume, that is kilogram per meter cube. Now Newton is a unit of force, and force is mass times acceleration. Mass is kilograms and acceleration is meter upon second squared. Therefore, if we further rearrange these units, Newton, which is force, can be written as kilogram meter upon second square times seconds times meter cube upon meter square times kilogram. So if we rearrange this equation, we get nu equals meter times meter upon second, which equals meter square upon second, which is the unit for nu or kinematic viscosity. Hence, we may remember that out of these two viscosities, the one whose units resemble to that of force is dynamic, and the one viscosity whose units resemble that of velocity, that is meter per second, is kinematic viscosity, dynamic and kinematic. So the answer for our question number 3 would be meter square upon second. We don't have that in options. That means we further need to rearrange this unit. Meter is 100 times a centimeter. Therefore, we are going to get 10 to the power 4 centimeter square per second. This is the answer for our question number 3, which is the option D, which you can relate from this derivation. Nu in terms of centimeters equals centimeter square per second. So the units of nu are centimeter square per second. From our options, it is the option number D. Now, let us discuss the the question number 4. The question number 4 states the unit of dynamic viscosity if the dynamic viscosity of a fluid is 0.5 poise. So let us note the details given in this question. Dynamic viscosity, that is mu, is 0.5 poise, and specific gravity is 0.5, and we need to find kinematic viscosity in Stokes. Okay, so we need to note a few things first. So far we have learned that the unit of dynamic viscosity is Newton second time upon meter square, and we need to remember 10 poise make 1 Newton second upon meter square. So poise is the smaller unit for the dynamic viscosity, and Newton second upon meter square, or Newton second per meter square, is the standard unit for the dynamic viscosity. So we need to remember this relation. 10 poises equal 1 Newton second upon meter square. Similarly, for kinematic viscosity, we have learned that the unit is meter square per second. Therefore, we need to remember that another unit of kinematic viscosity is a stoke, and 1 stoke equals 1 centimeter square per second. So in terms of meters, it is meter square per second, and in terms of centimeters, it is 1 centimeter square per second, which is exactly a stoke. So 1 stoke is 1 centimeter square per second. So we need to keep these relations between units in mind, and then we can go ahead with the solution of this question. So we need to find the dynamic viscosity, which is we need to find the kinematic viscosity, which is the dynamic viscosity upon density. And it is given that dynamic viscosity is 0.5 poise. So kinematic viscosity would be 0.5 poise upon the density. But in this question, we have not been detailed about the density. Rather, we have been given the specific gravity, which is 0.5. And specific gravity of any fluid is the density of that fluid upon the density of water. So the density of this fluid will be specific gravity times the density of water, which is 0.5, which is given in the details of this question, times the density of water, which is 1000 kilograms per meter cube of water. So the density of this fluid in question is going to be 500 kilograms per meter cube. Now let us further simplify nu, which is the kinematic viscosity, as 0.5 upon the density of this fluid, which is 500 kilograms per meter cube, times the poise. And we have detailed the definition of a poise here. So 10 poises make 1 Newton second upon meter square. So 1 poise can be taken as 1/10th of a Newton second per meter square. So we are close to the answer of this question. So 0.5 upon 500 times kilogram upon meter cube times 1/10th of a Newton second per meter square is the kinematic viscosity. Now we need to simplify and rearrange these numbers a bit. So 5 times 500 times 10 times kg upon meter cube times 1 by 10 times Newton second upon meter square. So 1 upon 1, 2, 3, and 4, 10 to the power 4 times 1 upon kg per meter cube. We need to break down this Newton here, and Newton is a unit of force, which is mass times acceleration. Mass is kilogram and acceleration is meter upon second square. So kilogram meter upon second square times meter square. So if you rearrange this equation, we're gonna get 1 upon 10 to the 4 times meter times meter upon second square. Times a second, which we missed here. So this is going to be 1 upon 10 to the power 4 times meter square upon second. So we are close to the unit of this viscosity as well as the value of this viscosity, which is 1 upon 10 to the power 4 times meter square per second. Now in this question, we have been asked the kinematic viscosity of the fluid in Stokes. So this is the standard unit of viscosity, and we have learned a little bit earlier that a Stoke equals a centimeter square upon a second. Therefore, nu, which is kinematic viscosity, equals 1 over 10 to the power 4 times a meter is 100 times a centimeter squared upon a second. So kinematic viscosity is going to be 10 to the power 4 100 squared, and then a centimeter squared, 10 to the power 4 from the equation upon a second. So kinematic viscosity is 1 centimeter square per second, or 1 Stoke. For this fluid, because a Stoke equals a centimeter square upon a second. 1 Stoke is 1 centimeter square per second. So the answer for this question is C, which is 1 Stoke. So the answer of question number 4 is C. The kinematic viscosity of the fluid is 1 Stoke. Thank you for watching.